Lesson 10.14, find horizontal asymptotes algebraically. So the last lesson was finding vertical asymptotes. Now we're finding horizontal. So obviously horizontal lines look like this. It's some imaginary line that the curved function will get really, really, really close to, but it never actually touches that value. And so there's three different cases that can happen. The first thing that happens is we're going to look at, these are polynomials on the top and the bottom, numerator, denominator. If the highest degree or exponent or power equals the degree on the bottom, so the top exponent equals the exponent on the bottom, then you're simply going to divide the coefficients, which are just the numbers in front of those highest exponent numbers. Okay, it's very, very simple. So that's thing number one, is if the powers on top and bottom equal each other. Then the next thing that can happen is that it's bottom heavy, or the degree on the bottom is bigger. So see how this has an x squared versus this is an x to the first, this power's higher. So that means that it's going to be just y equals 0, the x-axis. And then the last thing that can happen is that it can be top heavy, where the degree on the top is bigger than on the bottom. So see how it's x squared over x. That means there's going to have no horizontal asymptote. It actually has a slant asymptote, but for this assignment you just need to know that it does not have a horizontal. Okay, so let's try them. So what you're going to do is you're going to just make sure that you find the highest exponent on the top and the bottom. So I see x squared and I see x squared. They match. So my rule is to set y equal to, I'm going to divide those coefficients or those numbers, 6/5. Can't be simplified, can't divide, so that's it. This graph would have a horizontal asymptote at y equals 6/5. That is in standard form. Factored form, we're going to have to do just a little bit more work. I'm not going to even fully FOIL this. All I need to know is the biggest exponent term. So I know that's going to come from 2x times x, which is 2x squared. If you want to go ahead and FOIL, you can. That would get negative 4x, positive x, and 1 times negative 2 is negative 2. So see how none of them are as big as what I had first. And then this, I just need to take 2x times x, which is 2x squared. I don't care about the other term. So I look and I see, hey, it's an x squared over an x squared. They match. So y would equal, I'm going to divide 2 by 2, which means y equals 1 would be the horizontal asymptote. Okay, so the next one, I find the highest exponent. So see how I have an x to the first over x squared. It's bottom heavy. So think of these like normal fractions where it's like 1 over 2 or 3 over 4. They're normal, they're nice, they're neat, right? So on this one, I don't have to do any work. It's automatically the x-axis, which is y equals 0. That's it. Number 4 is factored form, so I have to do just a little bit of work. That would be a 3x would be my highest on the bottom. And then here, I'm going to get an x times x, which is an x squared, times 2, so I get over 2x squared. So see how, I don't like that there now. See how this is an x over an x squared? It's bottom heavy, so that automatically means the x-axis or the line y equals 0 is my asymptote. Okay, last case. They're top heavy, so find the highest degree or exponent. So you have x squared over x. Think of these as being like 3 over 2 or 5 over 4. These are called improper fractions. They're top heavy. They need to be fixed. They're not as neat as the other ones. They're going to have no horizontal asymptote. So as soon as I see they're top heavy, no horizontal asymptote. Okay, and then in factor form, I would just take 2x times 2x. That's 4x squared times this 3. And on the bottom, I have 3 times 2x is 6x. So you get 12x squared over 6x. I don't need to simplify, but I see that it is top heavy. It's x squared over x to the first. So no horizontal asymptote. And that's it.